Assalamualaikum warahmatullahi wabarakatuh. Today, in our fifth meeting, we will discuss about Visual Guided Approach or VGA. Since the earliest day of flying, pilots have used ground references for navigation when approaching an airport. It was just like a sailor at the sea. They have used landmarks on shore when approaching a harbor. So pilots need visual aids in good weather or bad weather, and during the day and at night. In the daytime, there is adequate light from the sun, so artificial lighting is not usually required, but it is necessary to have adequate contrast in the field of view and to have a suitable pattern of brightness so that the important features of the airport can be identified and oriented with respect to the position of the aircraft in space. These requirements are almost automatically met during the day when the weather is clear. The runway for conventional aircraft always appears as a long narrow strip with straight sides and is free from obstacles. It can therefore be easily identified from a distance or by flying over the field. Therefore, the perspective view of the runway and other identifying references, landmarks, are used by pilots as visual aids for orientation when they are approaching the airport to land. Experience has demonstrated that the horizon, the runway edge, the runway threshold, and the central line of the runway are the most important elements. So we have most important elements is the runway edge. Here is the runway edge, the threshold, and the center line of the runway. In order to enhance the visual information during the day, the runway is painted with standard marking patterns. The key elements in these patterns are threshold, the center lines, the edge, plus multiple parallel lines to increase the perspective and to define the plane of the surface. So let's talk about the visual guided approach. Visual guided approach is visual aids that assist the pilot on approach to an airport, as well as navigating around an airfield, and are essential elements of airport infrastructure. And today we will talk about 5 kinds of the visual guided approach. The first is the visual approach slope aids, REIL and ALS. So we will talk about this later. What is this and what kind of the visual guided approach is? We will talk later. And the second is wind direction indicator. The third is landing direction indicator. The fourth is airfield markings, and the last airfield lightings. First, we will talk about the visual approach slope aids. Visual approach slope aids are lighting systems designed to provide a measure of vertical guidance to aircraft approaching a particular runway. The principle of these aids is to provide color-based identification to the pilot, indicating their variation from a desired altitude and descent rate while on approach. The two most common visual approach slope aids are the visual approach slope indicator, or we will call it with FASI, and the precision approach path indicator, or we will call it as PAPI. So this is the PAPI one and this is the FASI one. This is the example. So the visual approach slope aids, we will help the pilot to do a landing. The light, like we can see here, this is the light and this is the light. The light will indicate whether the aircraft is in a good position or not to do a proper landing. The good position is like, is the aircraft is in the right height, the right angle, or else. So there are four kinds of visual approach slope aids. So basically there are two kinds of visual approach slope aids, FASI and PAPI, but FASI is divided into two kinds of visual approach slope aids again, and the PAPI is divided into two again. So there are four kinds of visual approach slope aids. There are T phases, AT phases, PAPI, and APAPI. The T phases shall consist of 20 lights units, so there are 20 lights. We can count it here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 multiplied by 2, so there are 20 lights units symmetrically. So this is symmetries between the left side and the right side, disposed about the runway center line in the form of two wing bars of 4 light units each. So this is the wing bars. There are two. This is the one, this is the second, and there are 4 lights, 1, 2, 3, 4 each side, with bisecting longitudinal lines of 6 lights. So this is the longitudinal lines of 6 lights. There are in the left and in the right one. The second is AT phases, that shall consist of 10 light units arranged on one side of the runway. So at AT phases, there are just in the one side of the runway, so there are 10 lights unit, and in the form of a single wing bar of 4 light units. So there is just single wing bar of 4 light units with a bisecting longitudinal line of 6 light. And the third is the PAPI system, that shall consist of a wing bar of 4 sharp transition multi-lamp or paired single lamp units equally spaced. So this is equally spaced, and the system shall be located on the left side of the runway unless it is physically impracticable to do so. So normally it is located in the left side of the runway. And the last is the APAPI system, that consists of a wing bar of two sharp transition multi-lamps. So there are two lamps that shall be located on the left side of the runway also. So this is the visual approach slope aids. Visual approach slope indicator system. So fuzzy is a system of lights which acts as an aid in defining the desired glide path in relatively good weather conditions. Fuzzy lighting intensities are designed to be visible from 3 to 5 miles during the day and up to 20 miles at night. A fuzzy system shall be provided to serve the approach to a runway whether or not the runway is served by other visual approach aids or by non-visual aids, where one or more of the following conditions exist. A. The runway is used by turbojet or other aircraft with similar approach guidance requirements. B. The pilots of any type of aircraft may have difficulty in judging the approach due to inadequate visual guidance, such as is experienced during an approach over water or featureless terrain by day, or in the absence of sufficient extraneous lights in the approach area by night, or misleading information such as is produced by deceptive surrounding terrain or runway slopes. C. The presence of objects in the approach area may involve serious hazard if an aeroplane descends below the normal approach path, particularly if there are no non-visual or other visual aids to give warning of such objects. D. Physical conditions at either end of the runway present a serious hazard in the event of an aeroplane undershooting or overrunning the runway. The last, terrain or prevalent meteorological conditions are such that the aeroplane may be subjected to unusual turbulence during approach. So now, how can the pilot will see the lamp or the lights? So the light units shall be constructed and arranged in such a manner that the pilot of an aircraft during an approach will, so the first condition, if the aircraft above the approach slope, so the approach slope actually is the right slope that aircraft can do a landing, a proper landing. So it is about 3 degrees of the angle. So if the aircraft above the approach slope to do a proper landing, the pilot will see the wing bars white. So this is the wing bars. They will see white wing bars and 1, 2, or maybe 3 fly down lights. So this is the fly down lights. This is the fly down lights. So the more fly down lights being visible, the higher the pilot is above the approach slope. So if the pilot see the wing bars and three fly down lights, so it means that the aircraft is so much above the approach slope, and the difference between the approach slope and the aircraft is really huge. And the second condition is when the aircraft is on the approach slope. This is the right slope to do a proper landing. So the pilot will just see the wing bars white. So when the pilot just see the wing bars white, so it is mean that the aircraft is in a good position and is ready to landing. And the third is when the aircraft below the approach slope. So the pilot will see the wing bars, the white wing bars, and one, two, or maybe three fly up lights white. So this is the lights, the fly up lights, and the more fly up lights being visible, the lower of the pilot is below the approach slope. So the better condition and is when the pilot is see the wing bars. So when on or above the approach slope, no light shall be visible from the fly up lights units. So when the aircraft on or above the approach slope, so there are no light from the fly up light units. And when the aircraft on or below the approach slope, so no light shall be visible from the fly down light units. So the pilot should have to see just wing bars white if they want to do a proper landing. So this is how the light is arranged, so the pilot can see a different color in a different height, in a different slope, and in a different angle of the aircraft. So it is about the angle of the light. So the second one is PAPI, or Precision Approach Path Indicator. So the FAA presently prefers the use of another type of visual approach indicator called the Precision Approach Path Indicator, or PAPI. The system gives more precise indications to the pilots of the approach path of the aircraft and utilizes only one bar as opposed to the minimum of two required by the fuzzy system. So by utilizing the color scheme on fuzzy system, the pilot is able to ascertain 5 approach angles relative to the proper glide slope as compared with 3 with the fuzzy system. One of the problems with the fuzzy system has been the lack of an immediate transition from one color indication to another, resulting in shades of color. The PAPI system resolves this problem by providing an instant transition from one color indication to another as a reaction to the descent path of the aircraft. An advantage of the system is that, that it is a one-bar system as opposed to the two-bar fuzzy system. So these results are, in the other words, puppy indicator is greater operating and maintenance cost economies and eliminates the need for the pilot to look at two bars to obtain glide slope indications. So this is the example of puppy light boxes. So for the puppy, how the pilot will see the light. So the wing bar of a puppy shall be constructed and arranged in such a manner that a pilot making an approach will, the first condition, when the aircraft is farther above the approach slope, so the pilot will see all the light units as white. So this is for the example. So this is when the aircraft have more than 3.5 degrees, and when the aircraft is above the approach slope, so the pilot will see the one unit nearest the runway as red and the three units farthest from the runway as white. So this is the example. So the aircraft is slightly high and about maybe 3.2 degrees. So the light nearest the runway becoming red, or the pilot will see it as red, and when the aircraft on the approach slope, so the pilot will see the two units nearest the runway as red and the two units farthest from the runway as white. So like this. So the two nearest lights from the runway is red and this is the white. So this is when the aircraft is in 3 degrees or on the approach slope or on the correct slope that the aircraft can do a proper landing. So the fourth is when the aircraft below the approach slope, so the pilot will see three units nearest the runway as red and the unit farthest from the runway as white. So this is the example. So the three units nearest the runway is red and the unit farthest from the runway as white. So the aircraft is in about slightly low from the approach slope or about 2 degrees. And the last is when the aircraft below the approach slope, so the pilot will see all the units as red. So this is maybe the aircraft less than 2.5 degrees. And this is the layout of the puppy. So this is the typical puppy wing bar, and this is the typical puppy wing bar. So the puppy is just two lamp and this four lamp, and the distance of one to other light is about 9 meters, like this. So this is the complete view of Boeing 747 400 at Sukhoi Airport. Aircraft is going to landing and the pilot
Approaching minimums. Minimums. 100. 50. 40. 30. 20. 10.